Hey guys, today we are going to touch on discriminants and nature of roots and managing common foundation questions related to it. So if you're ready, let's jump right in. The discriminant of a quadratic equation is simply b squared minus 4ac that you see in this quadratic formula. It helps us discriminate among the three possible types of roots. The first type of roots are real and distinct roots, as shown from the example quadratic equation here when we solve for x. Now notice that the roots are 2 and 1, and these numbers are real, yet different at the same time. So this always happens when b squared minus 4ac has a value of more than 0. The second type of roots are equal roots. Sometimes when you solve a quadratic equation, such as x squared minus 4x plus 4 equals to 0, the roots of the equation are the same. Thus, we call this equal roots. This scenario happens when b squared minus 4ac, or the discriminant, is equals to 0. The third type of roots are unreal roots. As the name suggests, the roots are unreal numbers such as these. This happens when b squared minus 4ac, or the discriminant, is negative. Now let's check out this very common question that you might see. We are going to find the values of k for which this quadratic equation has real and distinct roots. Now the very first step we can do is to rearrange the equation in descending powers of x. So in this case it is x squared minus 2x plus k minus 2 equals to 0. The next step is to state the condition for the real and distinct roots to happen. So recall that for real and distinct roots, b squared minus 4ac is more than 0. Substitute in the values of b, a, and c, which is minus 2 squared, minus 4 multiplied by 1 multiplied by k minus 2, and it is more than 0. Now the third step is to solve this inequality or the equation, which is 4 minus 4k plus 8 is more than 0, minus 4k more than minus 12. And to find the value of k, you have to divide it by minus 4 on both sides, making sure to change the inequality sign because you have divided both sides by a negative sign. Now k is less than 3. This means that if k is less than 3, b squared minus 4ac will be more than 0, and the roots of the equation will then be real and distinct. Now let's try another quadratic equation. X squared plus 4px plus 2 minus 4p squared equals to 0 has equal roots. So find the possible values of p. The very first step again is to rank or rearrange the quadratic equation in descending powers of x. This has been done for you. X squared plus 4px plus 2 minus 4p squared equals to 0. The next step is to state the condition where this scenario occurs. For equal roots, b squared minus 4ac is equals to 0. Substitute in the values of a, b, and c. We have 4p squared minus 4 multiplied by 1 and 2 minus 4p squared equals to 0. We will then have 16p squared minus 4, open a bracket, 4 minus 16p plus 16p squared, close bracket, equals to 0. Now 16p squared minus 16 plus 64p minus 64p squared is equals to 0. We can then divide each term by 16 to give us p squared minus 1 plus 4p minus 4p squared equals to 0. Simplifying further, we have minus 3p squared plus 4p minus 1 equals to 0. Now if we were to factorize this equation, we will have p equals to 1/3 or p is equals to 1. Now, if you need further practice in this area, do check out the free downloadable practice questions and worked answers that I've prepared, linked in the description box below. Wishing you success and all the best in your foundation building. Bye!